In this video, we're going to do some practice problems finding derivatives with functions with trig functions inside of them. So, first derivative is the derivative of 2 sine of 2x. What we're going to ask each step of the way is, now we have our big three derivative rules. We are going to ask each time, are we multiplying two functions together? Are we dividing? Is there function composition? Or is it just a straightforward derivative? So if we're multiplying two functions, we're going to use the product rule. If we are dividing, we're going to use the quotient rule. If it's function composition, we're going to use the chain rule. And otherwise, we're just going to do a straightforward derivative. And note that all of the problems can be boiled down to that question. Is it multiplication, division, function composition, or a straightforward derivative? So note that for this first problem, you might actually see that that is multiplication, but let's remember that we can just bring constants out in front. We really just have the derivative of sine of 2x. And that is function composition. And we're going to use the chain rule here. So the inside function here is 2x. And it is inside of the function sine of something, or sine of x. So this derivative is going to be equal to 2 from before, and then the derivative of sine, which is cosine. We're going to leave the inside function alone, and we're going to multiply by the derivative of the inside function. This is going to give us 2 cosine of 2x times 2, or if you want, 4 cosine of 2x. All right, so next problem, are we multiplying functions, dividing, we have function composition, or is this just a derivative that we know the answer without having to do any extra work? And in this case, again, we have the chain rule. We have function composition. That's not cosine times 3x squared minus 1. That is cosine of 3x squared minus 1. The inside function is 3x squared minus 1. And the outside function is cosine of something. So the derivative of cosine is negative sine. We're going to leave the inside function alone, 3x squared minus 1. And we're going to multiply by the derivative of the inside function. And this gives us negative sine of 3x squared minus 1 times this derivative, which is 6x. And there is our answer. So we're adding one more wrinkle to the problems we did in section 3.4, just that now we have 6 more derivative rules that we can use: sine, cosine, tangent, secant, cosecant, cotangent. All right, let's continue on. Next problem, e to the negative sine squared x. And once again, we have chain rule here. So e to the negative sine squared is going to be, the inside function is negative sine squared of x, and it is inside of e to the something. So the derivative here is going to be e to the inside function, negative sine squared, times the derivative of the inside, the derivative of negative sine squared. And now we have to do this derivative. So this derivative is, again, function composition. You could do a product rule kind of thing, sine times negative sine or something like that. But I think chain rule is going to be the best way to go about it. We have that the inside function is sine, and it is inside of negative something squared, or negative x squared. That may look kind of weird, but remember that this negative sine squared x is the same thing as negative sine of x squared. We just adopt the notation to get rid of the parentheses that the squared goes around the sign. So to write this answer down, we're going to bring everything without the derivative first. So this e negative sine squared x. The derivative of negative x squared is going to be negative 2x. We're going to leave the inside function alone. And we're going to multiply by the derivative of the inside function. So we're almost done here. This is going to be e to the negative sine squared x times negative 2 sine of x times the derivative of cosine, or sine, which is cosine. All right, again, tangent cubed, we could do with chain rule. We could do it with a product rule with tangent and tangent squared or something like that. But I think the easiest way to go about it is chain rule. So chain rule here, our inside function is tangent, and it is inside of something cubed, or x cubed. So the derivative of x cubed is 3 something squared. That is going to be tangent, the inside function. And then we're going to multiply by the derivative of the inside, tangent. That'll give us our final answer of 3 tangent squared times the derivative of tangent, which is secant squared x. So note that you could have done product rule here, but you'd have to do it twice. You could have done this as tangent times tangent squared of x, but you'd have to do product rule twice to kind of make that work, and that's a little bit gross. All right, one last problem. We have a big chain rule kind of problem, and all these problems have been chain rule, but it kind of starts the same with product and quotient. We'll do more examples of product and quotients in the next few videos as well. We have secant of cotangent of sine of 2x. And here's a good example of a multiple kind of chain rule sort of problem. So, as a whole, we have cotangent of sine of 2x inside of secant of x. So the chain rule says that we are going to take the derivative of secant which is secant tangent, and we're going to leave the inside function alone. So this is going to look really gross here. This is going to be secant tangent, where I'm going to leave this inside function alone, but it has to go in kind of both spots. Cotangent of sine of 2x and then times the derivative of the inside function. All right, so I am not going to rewrite every single thing, every single step until the last little bit. So now new problem, derivative of cotangent of sine of 2x. And this is, again, chain rule, where I have the inside function is sine of 2x, and the outside function is cotangent of x. And we know the derivative of cotangent is negative cosecant squared. So this derivative is going to be negative cosecant squared of sine of 2x times the derivative of sine of 2x. I now need to take care of the derivative of sine of 2x, and lo and behold, we have chain rule again. Inside function is 2x, outside function is sine, and we know the derivative of sine is cosine. So that's going to give us a cosine of 2x times the derivative of 2, and one more derivative. We know the derivative of 2 is the derivative of 2x, and the derivative of 2x is 2. So putting everything together, our final answer is secant of cotangent of sine of 2x tangent of cotangent of sine of 2x times negative cosecant squared of sine of 2x times cosine 2x times 2. Super gross answer, but there's a really complicated kind of problem we could do with all the chain rule. All right, in the next video, we're going to continue looking at derivatives of different functions, this time looking at logarithm functions and inverse trig functions.